Hey, what's up everyone? Welcome back to another video. In this video, we are going to do some advanced web scraping with Python. If you haven't already seen it, I recommend checking out my overview on the Python BeautifulSoup library. I'll pop it up right here. But this is going to kind of take that video and really build onto more advanced things that you might see in the wild. Web scraping is an incredibly useful skill. I do a lot of work on Upwork, and I feel like the most common thing that I ever see is web scraping jobs. So if you can master web scraping, you have tons of opportunities when it comes to freelance, when it comes to work, etc. Before we get into the video though, I want to give a shout out to this video's sponsor, and that is Bright Data. When it comes to really advanced web scraping stuff, it's hard to do it on your own. One of the things that I like most about Bright Data, our sponsor, is they offer all sorts of proxy tools, which basically allows you to send requests from many different locations, and it allows you to ultimately bypass a lot of the restrictions that sites try to implement to prevent you from scraping them. If you don't want to deal with learning how to web scrape and watching this whole tutorial, Bright Data also offers a bunch of data sets that are available for purchase, such as Walmart, which we'll be scraping today, but also Amazon, Airbnb, Instagram, LinkedIn, etc. So tons of data sets in the dataset marketplace that you could also just get started super quickly. But without further ado, let's get into this tutorial. All right, to demonstrate these advanced scraping techniques, we're going to be doing some scraping on walmart.com. And if this ever feels too quick for you, I recommend checking out the original video I did on BeautifulSoup, which will be linked in the description, and also I'll pop it up right here. The first thing we'll want to do with any sort of web scraping project is kind of identify the HTML of what we're trying to scrape. So let's say I was looking for a new computer monitor because, of course, I'm a programmer. I need 10,000 monitors at all times. So I look up monitor here. And let's see what looks good. Let's click on this first Samsung one. How about this Odyssey G6? We'll check that out. So if I was trying to web scrape and collect information because I want to pay the best price for these monitors, I'm going to be looking at the HTML on the page. So I might be trying to get this information. I might be able to, trying to get the save information, probably be trying to get this information, maybe the reviews information, bunch of things that I want to get. But the way that we do this in web scraping land is for most internet browsers, you can right click and click on inspect, which opens up the kind of HTML source code. So if we look in here, we can specifically click inspect on this tag and kind of find where the price is. One thing though that I also notice with this specific Walmart page is there's this concept of item props. So that kind of leads me to think that maybe there's another kind of technique going on here that's getting some of this information. If we look at all of the information on this page, I'm trying to see if there's anything that sticks out here. Yep, there we go. There's this next data field. Let's see what's in that. And we see in here, there's this massive JSON object that has props. So this next data tag is telling me this is a specific type of JavaScript project that leverages these props and passes them in on the web page. So instead of actually scraping from the HTML tags themselves, we can actually usually find the information we're looking for within this props field. So I think kind of our technique for scraping information from Walmart will be do a search like we just did. So we had, the search for monitor. This is a pretty easy format. I could very easily replace monitor here with other words and search for them, and then kind of programmatically go through this page, maybe click on items, and then once we're clicking on an item, we'll see for this monitor too, that it also has these page props. And then in this page props information, basically we'll want to look for and find where the actual price is within this nested JSON. So that's the general technique. Let's open up a code editor and kind of just write some template code out to help us do this. So I'm in this advanced scraping repo, and I'll link this in the description. I'll link my GitHub repo with all the code that we'll see in this video. But I'll just call this Walmart scraper.py. And probably the first thing we'll want to do is install BeautifulSoup. And I recommend if you know how to set up a virtual environment to do this. I'll link a video on how to do that right here. But we can go pip3 install BeautifulSoup 4. We see we already have it. And we're also going to want to use the requests library. So I'll just kind of template out some code and then kind of explain it more in depth in a sec. Often, like when I forget how to import things, I feel like BeautifulSoup is always a weird thing. I like using Copilot. And then I'll also want to import the requests library, and Walmart URL equals, how about https walmart.com/ maybe we grab a specific one of those pages that we had open. So I'm just going to steal this page real quick. That URL is this. So just take any product URL from Walmart. We got the curved ultra wide monitor. And then we'll want to get that. So response equals requests.get, pass in a URL, and we'll print out that HTML. Okay, so let's go ahead and do that. Cool, we get the HTML. And the next thing we'll want to do is get specifically that next data tag so we can start looking at what's in that. So if we look at our web page again, I inspect this next data. Basically, we'll want to find the script with the ID next data. So how do we do that with BeautifulSoup? So we'll say soup equals BeautifulSoup response.text. We'll use the HTML parser, and we'll specifically want to find that soup tag with the ID. So soup find script tag with ID next data. I think it was like this. We can change the ID if we have to. That looks good. Basically, we want to just print out the HTML again. And it says none. That is strange. Why does it say none? So let's make sure that the next data is correct. Next, 22 underscores. So that looks correct. And so this is the first, I think, like advanced feature that you'll have to know about. If you ever have a situation where you retrieve a page, it's usually one or two, and like the tag you're looking for is not there when you retrieve it with Python. It's either one of two things. One is that this is a dynamic page that like some of the stuff loads a little bit later. Or two, they're purposely hiding stuff from requests that don't look human. By default, there's certain headers when you use the requests library in Python. And so to get around and make ourselves look more human, we want to make sure that we mock whatever headers we use when we're actually making this request in the Python land. What I would probably do here to figure out what are good headers to use, look at our network, and any really one of these probably will be fine. And basically, we want to just copy the headers that we use in our actual web browser. So we have the request headers down here. If we copy some of these parameters, we'll probably find we have more success. So we probably want to copy the accept languages and the user agent tags. Which is good. And sometimes you might even want to like have this cycle between several different options, so you always are changing up what you look like. We'll add commas. That looks good. Cool. And so now what we can do with our requests library, and I guess I have to change the order of this slightly. We can pass in the headers equals the new headers that we've added. And now the question is, can we find this script tag? So we're going to go ahead and run all of this code. And look at that, we do get this next data field that we are looking for. Awesome. All right, now that we have this data here, we want to be able to grab specifically the price from this. So what I would recommend is, this is crazy complicated to look at. I feel like probably it's purposely like just super obfuscated to make it hard to grab everything. What I might do is go back to the web page, inspect, grab the next data. I might copy the element, and then what I might recommend doing is copy this JSON, go to like an online token counter. Probably a bunch of these will work. I'm just going to use this Streamlit app I see and paste in your JSON and then see how many tokens. So we see we have like 59,000 tokens. Not super friendly to, honestly, the like GPT 3.5. I think that's above any limits it can process. You could use GPT-4 if you have access to full 128K context. Basically, the goal is, can we look at what's in this without having to dig through all of this JSON? A couple different ways to do it. What we might do real quick, and we'll want to make this JSON, so we can do that by importing the JSON library as well. And then we can go ahead and we should be able to do something like data equals HTML or script tag dot string. That'll get all the text within it. We can do JSON.loads. And now we should be able to print out data.keys. Cool, look at that. So basically we can kind of keep repeating this process. We could get the props and then see what the keys of that are. It's going to be kind of a slow process, but I'm just kind of showing how you could do it manually. So what are the props of the keys, or the keys of the props? Page props, so we know we have to go into page props. And I'm thinking they're in props just because that's what, the JavaScript framework will leverage. Initial data sounds pretty good. I would say probably data, not headers. Probably product, but maybe also review information would be helpful too. Oh wow, now there's a lot of things. Now I'd look at if there's a price in here somewhere. Price. Do we see any price? Price info, I like that. Now what's in the price info one? Current price, I like that. This might be the end of our dictionary, we'll see. And then I think probably if we get price from this, let's see what we get. Look at that, that gives us $199. And if we look at the product that we were looking at, it is 100% $199. So that was getting information from this page. Not super easy, but the reason I was saying go to this token counter is if you have a large language model that has the ability to parse this number of tokens, what I might recommend is copying your code. Like for example, Claude, if you have the Pro version, can parse a lot. So I might say, what are the most important fields from the following JSON to get the price info and review info for the current product? Paste this in, which is crazy, very long. I'd say limit to just 10 items. Share full path to get to that field using Python syntax or something like that. And this looks like pretty good. I noticed that it's just going like 4 levels deep, so I feel like it skipped over the stuff to get to product. I might say, hey, wait, to get to product, you need to use the following path. Here's the code I found that works for price. Please adjust solutions accordingly. Copy this, paste it in. Perfect, this looks useful. So take this as an example, but you can use like large language models to help you parse massive amounts of JSON like this. But to simplify the process, if you go to the GitHub link, I'll share some a code snippet that will help us get the information we're looking for. So I'll go ahead and paste that in. Here we go. So here's a nice little product info dictionary, and I can go ahead and print product info for our current product. Look at that. Review count 239. Let's check to see if that's also valid. Look at that, 239 reviews. So this looks great. We're getting some information. I think the big thing though is if we wanted to collect a lot of information on products such as these monitors and collect it over time and every day maybe run something that gets all this information and it stores it in a database or something, we need to modify this a bit. So what might we do? Well, we can separate this into maybe two functions. One function will be called extract product info. And that will take in some sort of product URL. And we can basically just paste in what we already have. So this is product URL now. And instead of printing product info, we'll return product info. So that's one of our functions. And then the other function we might want to have is like get product pages or get product links or something like that. And what that might look like is maybe that takes in a query. If you remember how we got to this monitor page, the first thing we did was we did a search that looks like this. So I'm going to go ahead and copy this, call this like base URL or like search URL. How about search URL equals this, and then we can use an f string to flip out the search term and make that whatever our query is. I think the only other thing I might add to this is, let's say we wanted to scrape a bunch of information on monitors. Well, this is all the monitors, but what if we wanted more than just the first page of monitors? We might go to the second page, and we see that you can also leverage page information here. So I'm going to go ahead and copy that and put this also into my URL. So how about we also pass in a page number? And by default, it can start at 1. And we're going to do a similar type thing. Get all of the pages, or get this search URL. Then we would probably want to get all of the links from this. So if I look at this page, right click, inspect, we get this href here. Looks like this. These are our sponsored ones. Scroll out. These first ones are all sponsored, so I might just see what it looks like if it looks any different on non-sponsored ones. Okay, here's another link. And this, look at that, it's just it doesn't have the full URL, just has the kind of this part of it. So we'll want to be able to handle both cases. So grabbing all of those links might look something like, basically we want to find all the links in this. So find all A tags. We want to make sure that they have an href as part of it, because that's how we're going to access this information. And then we can do something like for link in links. And then we know that the product URLs, I think one little trick, always have this /IP in them. So what I might do to grab all the links and not get anything that's like a link to some other random page that's not super useful is I might check to see if in the text, so if this specific term is in link href. Href is the actual link stuff, so that's why we're looking at that specifically. And we basically want to add that link to some sort of queue. So I might add a list. And then we saw two different types of URLs. If HTTPS is in the URL, then basically our URL is already a full URL. Full URL. However, if it's just the IP stuff, then our full URL would be equal to, and then basically we will want to append this link to our product links. This is just basically things we'll search for. And then we'll want to return our product links. Cool. So now let's test out to see if this works. So let's create a main function. So how will we get product links for a search term like computers? Run that. And we do see we get a bunch of links. Cool, this looks pretty good. So now if we wanted to create some sort of kind of like, you could either do a database, use something like MongoDB or SQLite, or you could even save some of this stuff locally. It depends on how complex you want to get. But basically what we could do is do a loop over get product links and extract product info, and basically combine the two things and save the results. So what that might look like, I'm going to save this as a JSON lines file. So I'll call this output file equals and then we'll write to our output file. We can loop over a search query. So how about links equals product, or get product links, computers. How will we make this a while true? While true, links equals get product links, page number. And we can start popping off links, not product links. If not links, how about, or if we get, once we get past the first 100 pages, we're probably fine also breaking, or page number greater than 99. We'll break out of the loop, iterate over the links. And we will go ahead and product info equals extract product info on this link. And then if we do get a result or something like that, we might write to our file. And we should also add a new line to this because this is a JSON lines file. So basically each dictionary will be its own line. And it's probably good practice for us to surround this in a try except. And then we'll want to increase the page number by 1. And we might show that we're going to a next page. Cool. This is a basic way, but this should scrape all of our computer information, I believe. And we'll see if this works. There we go. Oops, messed up the syntax there. And while this runs, we can kind of check to see if it's working by looking at the file and see if lines of JSON are being added. And we do see items being added. Again, all of the code is linked in the description, and I'll kind of break it down by where we're at in the video. So that finished scraping, and if we look at our product info, we can see we have a bunch of products scraped. I think there's a couple ways that I would improve this though. I think one of the big ones is that this wasn't quite smart on what products we scraped. So if you look, you'll see like some items pop up all the time, like this Acer Chromebook. So there's two different ways you could kind of solve this problem. Is you could check the item ID and only add items to your kind of queue of links to search if you hadn't already added it already, and you could do that by the item ID. Or you could, kind of the simpler solution might be just look at the link that you're scraping here, and if you've already seen that link before, don't scrape the info. Another thing we might want to do too is that this ran successfully, but we only had one search term, computers. What if you wanted to look up a bunch of things? What would that look like? And would this same system be able to operate there? I'm going to paste in some code with these changes. Again, both the code you see currently and this new code, all available in the description on GitHub. But we'll go ahead and paste this in. A couple changes now. Some of the variable names have changed, but we have now multiple search queries, so computers is still there. But we have other items as well that we're going to be looking at. And we're going to use a queue to kind of keep track of what products to look at, as well as we'll keep track of URLs we've already seen in this seen URLs. But the process is just about the same. Also have some print statements to kind of show what we're doing. Run a query, get all of the links, same as before, add it to the product info. But now we can just scrape more info. And what does that look like? We can go ahead and run this. And we see all the URLs processing. One issue is that we just overwrote the original file we made. So this is why you might want to go to like an online MongoDB where you're always just adding items to something instead of doing the risky way of writing local files. Because this video is focused on web scraping, not necessarily how to output things, I'm going to leave it as is for now, but that's kind of one way you could improve this project on your own. And so I'll fast forward and let this run. And ultimately, so what you'll see is that it ran a bunch of these products, but as we got through different search queries, eventually Walmart blocked our IP address and basically said no more scraping. It kind of saw that what we were doing because we kept making requests with the same exact IP address, and it does not like that. So what do you do if you're in this situation where you need to keep scraping, but you're physically getting blocked by a site like Walmart.com that's not liking what you're doing? This is exactly where Bright Data comes in. So if you use the link in the description, you'll get $15 free for Bright Data. But basically, our IP got blocked and you still want to scrape. So this is where some Bright Data tools can come in. So I already created an account, but if you haven't, I recommend starting free trial or setting up with Google. Again, link in the description will give you $15 free. So definitely sign up using that link. I'm going to go to my user dashboard. And what we'll do to start, I'll show some other stuff, but we're going to use what's known as a proxy. So basically, a proxy network allows us to send requests from different spots, basically. So if you think of the way we normally do it, we have one single computer, which has a IP address associated with it, and every request has that IP. When you use a Bright Data proxy server, our request goes through Bright Data, and then Bright Data allows us to make requests as many different IPs, many different locations, and thus makes it much, much more difficult to block the requests we're making. Basically, we can set our proxy server up in whatever way so that we make sure that we get our requests through. So we're going to click on View Proxy Products, and we can go ahead and add a new one. I think that I would recommend probably a good starting point is data center proxies. And there's different ways you can approach this. Let's say you needed to use the same IP address for every one of your requests when you come back and run this again. Maybe you had some sort of whitelisting on a server that it's communicating with, and you wanted to make sure it was a set number of IPs. You could do dedicated, you could also do premium. But I think for most use cases, the shared pool of data center IPs is probably gonna be exactly what you need. This basically is just a massive pool of different IP addresses, and different people at different times can use from this pool. Here we see number of IPs. So we're not going to play around with here. What we can do is actually go into advanced options, and I'm going to switch to pay for usage. Basically gives us access to 10,000 plus IPs. It really depends on how much you expect to use. What I'd recommend is you can kind of, as you run your jobs, you can kind of see the costs and decide whether or not paying per IP or paying per usage makes more sense. I'll give this a name called like scraping proxy. And so we're going to go ahead and add this. Yes. There's some advanced options here, but the most important thing we will want to do is basically keep track of our host username and password. I'll blur these out. I'll show you how we can actually leverage this information in our BeautifulSoup requests. We also can see statistics as we actually start using our proxy, but we see some example Python code here. If we go into the documentation, I believe we can see some more Python code. I like this a lot. This already has some requests library stuff. I think we can go ahead basically and copy this all into our code. So I'm going to paste this in. Our username and password will have to change. What I recommend for username and password is you can create a .env file in your repo. You can set I'm going to call this a bright data username equals and a bright data password equals, and we'll just do this for example, test and test password. And then basically on our code side, what we can do, okay, so in our code, we could just run this, but we can just modify our existing code to leverage this. We need to fix our username and password, so what we can do is import what's known as .env. And actually what we'll want to do is from .env import load.env. And if we run load.env, basically this then creates environment variables for us to use based on the environment we set here in our .env file that's within the same folder as our scraper code. Also want to import OS. And now basically what we can do is if I went ahead and set this to os.environ brd username, and we set this to os.environ brd password, what we'll see is if I print username and print password, we'll see those test variables that we put in. I'm going to temporarily comment out all this bottom code. All right, run the file. Test password, cool. So now I'm going to actually paste in my password and my username from the zone we created. Next time I run, we'll have access to that. And now we see that in our request.get, we can use proxies. There's also this cool thing where we can do this myip.json and make our request there and actually see where the IP is that we're sending our request from. So let's go ahead and uncomment all of this. Again, I'm going to delete this example code real quick and I'll show how we can incorporate it in. Okay, so, and I think, do we need to change the host at all? Let's just check. Nope, the host looks good. It's what it has in the docs. Docs are also linked in the description, but we can go ahead now and as a little sample, I'm going to just use this URL instead of the search URL. And I'll do the same thing with the product URL. And I just want to show what happens if I do print.response.json here. So we've just temporarily put in this URL. We run this. And basically, we see always the same IP address. But if we then decided to insert proxies equal proxies, so we set our proxies here, based on this proxy URL, which contains our username and password and the host info. Then what we get after saving that and including the proxies in both of our requests, when we start printing out things, we see different IP addresses every time we send. So this little URL is cool for showing where these requests are coming from. And we see it's different countries and everything. Very cool. It proves that our proxies are working by passing in proxies like this. We can go ahead and keep the URL as we expected it to be. Move this print statement. Okay, our proxies are passed in. I'm going to delete this stuff, kind of clean up the code a little bit. But now we have access to the Bright Data proxy, which when we got blocked last time, now that we have the Bright Data proxy set, that for all these search queries, we can run them and basically get around the block that will happen when we use only a single IP. So that's pretty cool. If you're running into any errors with accessing things, you might have to do a pip3 install of any new library such as .env, or we also included prettyprint here. So make sure to pip3 install these items if you didn't. Now, by using proxies, we kind of open ourselves up to some other new kind of potential issues that we want to be aware of. One is maybe the proxy is not available for a second and a request trips up, or maybe the specific country that we used in our proxy request can't access the website we're trying to scrape. So we want to make sure we can fail gracefully if those types of things happen. Many different ways to do this, but basically I feel like it comes down to just being cognizant in a try except to handle failures properly. So I'm going to add in some additional error handling and paste in kind of a more error-proof way to do this. But within the Bright Data ecosystem, I think one thing that I would recommend is when you are looking at the proxies and the different things, kind of in the data, you could add specific geolocation targeting in either the shared or dedicated, and you see maybe you only wanted it to be United States, and maybe you can even add cities. That's pretty cool. Canada. So this would limit where your IPs are coming from. So if you find yourself getting blocked based on the location, look at things like this with geolocation targeting or specific cities. You can go very sophisticated, pretty cool stuff. So that's good to keep in mind. All right, but I'm going to go ahead and paste in a version of this that handles some failures a little bit more sophisticated manner. And also I'm going to use more search terms, because one of the perks of using the proxy networks is we could just keep scraping things. Quite nice. So basically just retries things. Basically the difference here with this code is it will retry getting product links or retry extracting product info with a max number of retries for each URL. And if it fails ever, it will sleep a certain amount of time that's dependent on what we defined as the backoff factor and the attempt number, and just basically let us make sure that if anything kind of hiccups, that we can process it. Another way you might improve this further is you could run things in parallel. It really depends on what's most important to you, whether it's just getting the info or getting the info quickly. There's different ways you could play around with this and improve it further, but this is a good starting point. You might get blocked in a couple thousand requests on Walmart. Normally you can do tens and tens of thousands when using a Bright Data proxy network, which is super nice. So I think this covers a lot of the kind of what you'll need to know when it comes to advanced scraping techniques. But I think the next logical step to take your skills even further is being able to actually automate actions on a page using a library such as Selenium in Python. So if you look up something like Selenium, Python, Bright Data, you can find some good information on how to kind of get started using Selenium. And really, yeah, Selenium is going to come in when you, let's say, page loads, but there's this table that loads a little bit slower, and maybe after like 5 seconds it loads in, and you need to access the information in the page. You can use Selenium to like load the page, wait 5 seconds, and then access the information that is slow to load by using things such as implicitly wait here through Selenium. And then additionally, one thing that's super useful within the Bright Data ecosystem is this scraping browser. So if you look at documentation, scraping browser, configuration, Python, Selenium, you can find some information on how to use it. But one thing that's really nice about the scraping browser is if, let's say you're using Selenium and you run into some CAPTCHAs and stuff that are particularly hard to get by, the scraping browser can kind of help you automatically bypass those, so you can really access that tricky to grab data programmatically. I think because this video is already a good length, we're going to hold off on all of that. If you want to see Selenium, Python, Bright Data stuff in more depth, let me know in the comments, and I definitely will make another follow-up video happen. But I think this was a good launching off point that builds off the kind of the basics that we learned in the original tutorial. Hopefully you now have a little bit more tools in your tool case, especially the Bright Data proxy stuff that can help you kind of take your scraping skills to the next level. With that, I think we'll call the video. I hope you learned something. I hope you enjoyed this video. If you did, it means a lot if you throw it a thumbs up and click the subscribe button if you haven't already. Yeah, got a bunch of tutorials on the way. Thank you to Bright Data again for sponsoring this video. Link to get your first $15 free on Bright Data down in the description. I think that is it. Until next time, everyone, peace out. One quick question before we go. I'm just super curious how all of you plan on taking the knowledge from this video on accessing web data via web scraping and applying it to your own projects. So would be super curious to hear what types of projects you all want to work on with this knowledge. Let me know in the comments. It's always fun to read through what you all are working on. All right, now I'm really out. Peace. Ow.